StoryHinge, Episode 11, Perry Marshall, Evolution 2.0.
Darwinists underestimate nature. Creationists underestimate God.
In this episode, we spend time with Perry Marshall, author of the book Evolution 2.0, where he presents a new way of looking at evolution, where it's not the typical neo-Darwinism, nor is it the traditional creationism side, but in a new place. And it was really fun and presented some really thought-provoking ideas. I hope you enjoy. Well, Perry, good to have you. Welcome to StoryHinge.
Thank you. Thank you for having me. It's a pleasure to be here, Jason.
I'm so excited to hear more about your story and to hear a little bit about your profession and especially about your new book, Evolution 2.0. So walk through your life and bring it up to where you're at today.
Well, I'm a business and marketing consultant. I wrote the world's best-selling book on Google advertising and some other marketing books, and you can find me on Amazon. And we're here to talk about biological evolution of all things, and that story really starts when I was having an argument with my younger brother on a bus in China. Brian had moved to China a few years before, and part of the time he was teaching English, part of the time he was a missionary. He had a master's degree in theology. Both of us came from this really conservative family in Nebraska. My dad was a minister. And what was happening was Brian was chucking his faith out the window. He was like, I don't believe this anymore. And this, as you might expect, was rather interesting. And I was a Christian, and actually the emails had been going back and forth for a couple of years already. So this was not a new conversation, but he was just going farther and farther. And finally, I was feeling flustered, and I said, okay, Brian, hang on a second. I said, look at the hand at the end of your arm. I said, this is a nice piece of engineering. And I'm speaking as an electrical engineer. Like, there's things when you're an engineer that you notice that most people overlook. I'm also, not only am I seeing good engineering, I'm seeing extremely artful use, how you deal with compromises and all this stuff. And I said, this is a fine piece of engineering. And I said, you don't think this is a random accumulation of accidents, do you? And he's like, hang on, buddy. And he just pushed right back. And what he says to me, he goes, look, if I got a billion falcons flying around all over the world and I got hundreds of millions of years, that's a lot of falcons, bro. And he goes, all you need is like, maybe a mutation or a copying error every now and then in the DNA. And occasionally it's going to be an improvement. And then its eyes can see better, and then it can hunt better, and then it outcompetes all the other falcons, and everything gets better and better and better.
So that's essentially the kind of the classical Darwinism, natural selection kind of view.
Yep.
Okay.
Totally the old school classical Darwin natural selection story, right?
Mm-hmm.
Now, I did not instantly buy this explanation that he was giving me. It's not like I hadn't heard it before. However, I knew a couple of things. I knew that most biologists would agree with him, not me. And I knew I wasn't a biologist. I thought to myself, this is very counterintuitive. This violates entropy, but I know they have answers for that. I don't know if the answers are right, but and I knew also I'm an electrical engineer. I knew there's some things in engineering that are extremely counterintuitive. You would never think that they were possible, but in fact they are. And so I didn't know what to say to that, being that it's like Brian was really dragging me along with him in this, journey away from faith. And I didn't really want to go there, but I knew maybe he might be right. And so I decided on that trip, it's like we're together for a week and I was seeing what he's doing and we're going around and we're sort of doing the tourist thing in China, but we're kind of arguing all week at the same time. So it was kind of, it's kind of like that. It was rather contentious. And on the plane ride home, I decided, you know what? I'm going to let science answer this question for me. I'm going to follow the evidence where it leads, and I'm going to find out.
Wow.
I'm going to figure this out. Like, if you just have billiard balls banging around in the universe long enough, does it eventually result in us?
Mm-hmm.
Okay. And so I said, I am going to go after this thing. And I remembered certain projects I worked on in school. Like there was a paper that I worked on. It was an acoustics problem, and it was a rather difficult one. And like I had to take this big complicated system, and I had to work it all the way down to literally Newton's law and just like build it all step by step until I had this whole problem figured out. It's like, okay, I have done like really fundamental science before. I'm going to find what is the absolute fundamental science here, because I don't know. And so I plunged myself in.
And as you're going through that, I guess I'm curious on what are you feeling on that? Because this might put your faith on the chopping block, perhaps.
My faith was on the chopping block. My whole worldview was on the chopping block. And, some people of faith might run screaming from the room and go, "You can't do that." I'm like, well, I did. And it was scary. It really was. It was terrifying. Like maybe by Thanksgiving, I'll be an atheist and we'll have Thanksgiving dinner and we'll have these arguments about religion that we had never used to have before. Like, I don't know what's going to happen. I don't know where this is going, but I'm going to find out.
And what would have been your reaction? I guess, was there family concerns on this? And you said your father was a minister and.
Well, so yeah, all my immediate family are all Christian, and, and I had a wife at the time, 4 kids, and we're all like taking them to Sunday school and everything, but I'm intellectually honest. Like, I can't like just be a fake Christian for the rest of my life, just keep the peace. I'm not that kind of guy. Like, I would never do that. If I disagreed with something, I would tell you, at least it was important, and this is important. So yeah, like I was on the edge, man, and I plunged myself into the abyss. It's like I'm falling and I don't know what I'm going to grab onto.
That's awesome. I mean, that takes a lot of courage. I've gone through some faith transition in my own life, and it's been a fairly disruptive activity to myself, to the family. But I appreciate that view of that being intellectually honest and saying, well, I want to be honest with myself. I have to live with myself. I'll take this where it goes. So why don't you take us to the next part of this story?
Well, and here's why I was willing to do that. I mean, that's a pretty heavy coat to put on that hanger, on the hanger of science, if you will. But here's the thing. I have a degree in engineering, and I've practiced engineering in quite a few different ways in different industries. And I also have a very in-depth theological education. And when you get into these arguments about whether Christianity is true and all this kind of stuff, there's a lot there. There's a lot to talk about. There's a lot of evidence to consider. Okay. I mean, a lot. The theological stuff tends to get a little squishy. The historical stuff tends to get a little squishy, and the science is not squishy. Okay? Science is very exact. And the reason that I was willing to do this was I can build a circuit, and I can predict before I build the circuit what's going to happen and how it's going to work. And guess what? It works.
Yeah.
Right?
Yeah.
And like, I know certain things. So I ought to be able to absolutely figure out, can a bunch of DNA copying errors and survival of the fittest turn, one bacterium into an entire ecosystem and a planet with millions of species and billions of people? Can that happen? I can figure this out. There's got to be a way to do it. And if this is true, somebody's absolutely proven that it's true somewhere. If all these scientists believe this, so, and also, I also knew that there's going to be some subtlety to this thing. Okay. There's probably going to be some unexpected twists and turns in the journey. So here we go. So what did I do? So I get home. Well, and I'm obsessive. I mean, look, anybody that like writes books for a living and does what I do, entrepreneurs, pretty much all entrepreneurs are obsessive, compulsive personalities. And so like I'm buying books. Like I think Amazon stock is probably going up because I'm buying so many books, and I'm on all these websites and I'm watching videos, and like I'm tearing into it. Right. So here's what happens. At first, the first thing I notice is this conversation is completely dominated by two polar opposite sides, and they both shout really loud. And at first, you walk into this and you watch the ping pong ball go back and forth between these two sides. And I sit there and go, you know what? That makes sense. But actually, that other thing doesn't make sense. And then I look at the other side and I go, that makes sense. But wait a minute, that one thing you said, that doesn't make sense. And after a while, I figured out if I listen to the loud people, I'm never going to figure this out. I actually have to go deeper. I have to start reading scientific papers. I'm not going to figure this out reading a Richard Dawkins book because it's too shallow. Okay. I'm not going to figure this out reading a Ken Ham Answers in Genesis book. It's too shallow. Okay. Like this stuff is written for popular people who do not understand science. It's dumbed down. And so I start digging deeper and deeper. So here's what happens. I had a series of epiphanies. And by the way, this ultimately, it took about 5 years to get to where I really felt like I had my arms around more or less the whole thing. But within a month or two, here's what happened. I said, okay, they're telling me that DNA copying errors could occasionally give you better falcons. Is that true? And what are DNA mutations and how does that work? So I'm reading about DNA and I'm finding out how the genetic code works. Okay, that makes perfect sense. And then I find out that it's structured. There are genes, there are chromosomes, there are larger and larger units. And I'm finding out how it's transcribed and then it's translated as it's converted into RNAs. And I suddenly realize, wait a minute, I've seen this before. Okay, and here's what it was. In 2002, I wrote a book called Industrial Ethernet for ISA, which is the world's largest professional society of process and control systems engineers. Okay? And I spent 6 years of my career selling digital networking to manufacturing facilities. Okay? And I had companies like Chrysler and Applied Materials. They're the guys who make Pentium chip, the machines that make Pentium chips. Okay, like very sophisticated people. Automotive industry, material handling, all these different industries. And we sold this networking gear, and the editor of their books called me up. He goes, I love your magazine articles. Would you write an Ethernet book? And so I wrote an Ethernet book. Now, an Ethernet book is like, could totally put you to sleep, right? But it's actually, if you can get past the surface, it's actually very fascinating. I mean, if you stop and think about it. So you and I were recording this on Skype, and what's happening like thousands of times a second is my audio signal is being digitally encoded. It's being inserted into a digital packet. It's getting sent across the internet, and it's being unpacked on the other side. And I know how that works. I understand what goes on. Okay. And it's ingenious, and there's layers and layers of these very clever things that go on. And I was asking myself the question, I said, when I was in engineering school, they never ever taught me about random mutation and natural selection. It never even came up. As some sort of design principle, it wasn't even mentioned in 5.5 years of engineering school. So either engineers know something the biologists know, or the biologists know something and the engineers don't know, and we should be talking to each other So, like, what's going on here? Now, in a little while, this is going to take a really interesting twist that I really didn't see coming when I started, okay? But back to the Ethernet thing. I look at this and I go, wait a minute. DNA is digital code. A strand of DNA is mathematically identical to an Ethernet packet. All of the principles of how you get the message from A to B are exactly the same.
In terms of like the packaging where you have something packaged within something else, So
it's ones and zeros. So, my voice gets turned into a format, where that waveform going up and down is sliced into pieces. And, every little piece is like, there's a number and the number gets converted to a voltage and it does it 44,000 times a second and you get audio. All right. And then you take that and you fold that inside an Ethernet in a TCP/IP packet, and that gets folded inside an Ethernet packet or a Wi-Fi or a cell phone signal or whatever. So you have these layers and layers and layers of a message inside a message inside a message. In fact, it's like Russian matryoshka dolls is what it is. It's like a doll inside a doll inside a doll inside a doll. This is how all this works. And what I found out is the matryoshka dolls is exactly the way DNA works also. And so people know that there are base pairs in DNA. They know that there's ACGTs. They know that there's genes and chromosomes, and that's about as many words as most people know. But right there, you have 4 layers of information in DNA. And actually, there might be hundreds of layers, but it's in principle, it's the same as digital data. And I'm like, okay, I can understand this. I can totally understand this. This is what I was looking for. Like, I was trying to touch the bottom of the swimming pool. How does this stuff work? I know. Now I know. So guess what? Evolution is a software engineering problem. No, it's also a chemical engineering problem.
Yeah.
It's a bunch of other things too. Okay, but at least we can take a slice and we can say, so how does that work? So let's connect a few dots here. First of all, there's a million codes out there, right? There's barcodes, zip codes, Morse codes, QR codes, postal codes, English, Chinese, PHP, HTML, right? Yep. There's a million codes. Guess what? 999,999 of them are designed. And there's one code and we don't know where it came from, and it's the genetic code. And there are no codes that aren't designed. There is no such thing known to man currently in scientific exploration. Yeah. In fact, you can divide the world into 2 camps. There's stuff that has codes and there's stuff that doesn't. Rocks don't have codes. Snowflakes don't have codes. Sunlight doesn't have codes. Quasars, black holes, none of that stuff has codes. Okay? Cells have codes. Humans make codes. Computers make codes. Language has codes. And it's like, it's a completely different world. So like, imagine going to a planet where there's no life forms. There is no communication. There is no data. There's no ones and zeros. It's just chemistry. But you come to Earth and there's all this information and there's this consciousness and there's living things. And everybody knows living things do a whole bunch of things that non-living things don't do. So it's like there's these 2 divisions in the world, and they are radically different. And nobody knows how to get from chemicals to code. Nobody knows how to do it. So right away, just figuring that much out, this provided a very strong inference or implication of design. It doesn't prove that DNA is designed, but I can tell you this, when I realized that, and now, well, geez, I wrote a whole Ethernet book. I've got charts and tables of how the packets are broken apart. I've got chapters about error detection and error correction, and digital data is very, very, very fragile. And there are no exceptions. There's no such thing as data that's not fragile. In fact, you and I were here on Skype, and our computers are running millions of instructions per second, and they're processing all this data and putting it in. There is no tolerance for error when those packets, and we know what it sounds like when your Skype call is breaking up.
Mm-hmm.
We know what it sounds like when your cell phone is breaking up. We've all seen on a TV or a video when all of a sudden the signal is getting scrambled and you get like that digital, like it just like turns to mush.
Mm-hmm.
Those of us who are old enough remember all the analog TVs with adjusting your antennas and all that. Yeah. Signals, snow on the TV and the channel doesn't come in very well, and your AM radio doesn't pick up. Okay. All of this is examples of how fragile signals are. So here's another thing that does not exist in electrical engineering. Random mutation occasionally making a better falcon eye doesn't exist. Yeah. It simply doesn't exist. A communication engineer never encounters that concept anywhere in their entire career. It's non-existent. You spend your entire life in digital data. If you're an IT guy, if you make modems, if you make routers, if you make TV antennas, you spend your entire life fighting random mutation, which are noise. It's noise. Random mutations are noise. It's the same thing.
Okay.
It's unexpected, unwanted interruption of the communication, whether it's one bit or whether the whole thing gets trashed. It's garbage and it destroys your data. And people don't really know this, but most software programs, most Microsoft Word files, most spreadsheets, most Skype packets, or most MP3 files, all you have to do is corrupt a few bits or bytes and the whole thing is just trashed.
Okay. So you're saying that you never, in the codes that we've all created, we've never seen it where that little messing up actually somehow creates something even better.
It can happen on a extraordinarily rare basis, but you could never, ever rely on it, ever.
Okay.
It could never be relied on to get you from, bacteria to people or anything like that. Now, so if you're paying attention, you're probably thinking, I'm going to say, so therefore evolution isn't true.
Yeah, this kind of sounds where you're going right now, but.
And that's not where I'm going with this.
Okay.
And this is where it gets really interesting. I mean, this is where it got really interesting. I figured out, all right, so cells have to have error correction in order to work, just like your Wi-Fi has to have error correction. Like people have no idea when they're driving down the expressway and they're talking on their phone or watching a YouTube video or whatever you're supposed to not be doing when you drive. There's all kinds of the whole time as the signal's going back and forth. Is that correct? Is that correct? No, resend, no, resend. Like there's all this negotiation that's going on all the time. Okay, I got this part of the packet. I didn't get that part of the packet. Resend it. There's extraordinarily clever error checking mechanisms that are built in multiple times. You have no idea. Like the stuff works. You have no idea how many, like in our Skype conversation, I bet there's at least 5, if not 10 different layers. Like every single Russian doll inside the Russian doll has its own error correction system going on. Okay. Like you can't believe how sophisticated all of this is. And I found out that all of that is in cells. All of that, it's in every cell of your body. And actually when a cell reproduces, the natural error rate of the first stage of DNA replication, when a cell replicates DNA, will get one error in 10,000 letters.
Uh-huh.
That's not nearly good enough. And there's a 3-stage error checking mechanism that gets you to 1 in a billion.
And I guess this kind of talks to how fragile the code is that you mentioned before.
It's extremely fragile. So, for example, cystic fibrosis. It's a horrible disease. It has hundreds of symptoms. It comes from deleting one codon, which is 3 little letters, in 3 billion base pairs of DNA. It's a 1 in a billion error corruption, and you get cystic fibrosis.
Wow.
Okay? It's incredible. Data is incredibly fragile. So I knew this, and I was tempted to stop. I was like, wow, this is all very creative. It's all very designed. In fact, we think we invented all these error correction schemes in the 50s and 60s and 70s, and actually they've been in cells for 4 billion years. Wow. Therefore, evolution isn't true. Therefore, I'm a creationist. And there's lots of engineers who are creationists, and that's exactly where they land. But I kept reading, and I kept looking, because I saw a lot of anecdotal evidence for evolution. And I said, I think there's more to the story. And it took a couple years, but one day this guy sent me a paper by a scientist at the University of Chicago named James Shapiro. And Shapiro was talking about these error correction mechanisms. In fact, I learned about this 3-stage correction system from Shapiro. Well, what Shapiro explained was not only do cells correct errors, when they have an error that they can't correct, they improvise, which your Skype doesn't do, your Ethernet packet doesn't do, your router doesn't do, your cell phone doesn't do. Cells do something that no human technology knows how to do. And I found about a fascinating experiment in 1944. There's a woman named Barbara McClintock. She was doing these experiments, and Barbara thought like a hacker. She and most biologists, they're not engineers. They don't think like engineers, but she brought kind of this hacker mentality. And what she was doing, she was breaking DNA in corn plants by sending these carefully metered doses of X-ray radiation, and they were breaking up the data packets. And she had this particular idea of something she wanted to do, and she tried it, and she kind of threw the plant a curveball, and the corn plant threw a curveball right back. And basically what happened was she broke a piece of DNA, and the chromosome has these ends that are supposed to be a certain way, just like all data packets. Like data packets have a structure. It's like, here's the beginning, and here's the middle, and here's the end. It's like, hello, conversation, goodbye. It's like that. Basically, the hello and the goodbye got broken off, and the plant didn't know what to do with this thing. And it kept working with it, and eventually it grabbed these other parts from some other chromosome, stuck them on, did this massive rearrangement of DNA, and was able to reproduce, because the plant wanted to reproduce and it couldn't reproduce if the chromosome was broken.
That's crazy.
Okay. and I mean, literally, it's almost like this page of this book is ripped out and I don't know what it says, so I can't, you know what? I think this other book has a page that I can stick in there and it'll work. Or a paragraph, like a missing paragraph, let's say, and it did it, and it worked. And she figured out what had happened, and she documented it all. 1944. So she went and presented this at a symposium, and all these scientists, half of them laughed at her, like, are you crazy, woman? Like, are you trying to tell us that a corn plant modifies its own genetics? Are you crazy? The other half were just like angry. They're like, this is nutty. Like, who is this person? Now, she was actually a fairly respected person in the profession, but they just had no grid for this, and they totally rejected it. So she knew she was right, but she knew she wasn't going to get anywhere with the standard profession. So she just went dark for about 20 years. And she published just enough stuff to keep her funding, but she had this whole skunkworks experiment going. Well, by the 70s, a bunch of other people started seeing this same stuff in other organisms. And she won the Nobel Prize in 1983, 39 years later. I mean, she was in her 80s when she got the Nobel Prize. But she discovered this thing called transposition, which is that cells can rearrange their DNA. In fact, there are situations where certain kind of cells, when you put them under extreme stress, like they're starving, there's nutrients that they can't digest, there's some kind of super hostile situation and they're going to die, they'll cut their DNA into as many as 100,000 pieces and rearrange it. So this is like software that completely rewrites itself.
That blows me away. And it's like there's an intelligence there that's doing this, or
the cell does this. Barbara McClintock asked the question. I think this is one of the greatest questions in all of science. What does a cell know about itself? Now, the answer is, I don't know. She doesn't know. Nobody knows. But certainly it knows something. Okay? And so, like, if you watch a YouTube video and you watch a bunch of white blood cells chasing around germs in your bloodstream, those suckers have a goal. They are trying to accomplish something. And most people don't know that every cell in your body, except for blood cells, which is a whole nother, but pretty much every cell in your body has the ability to cut, splice, rearrange, and reorganize its DNA. And this goes on all the time for very specific reasons, like in your immune system. Your immune system is constantly reconfiguring stuff and figuring out how to fight the bad guys. This goes on all the time. Barbara McClintock's corn plant evolved because it was presented with a hostile situation that was going to kill it and prevent it from reproducing. And so it re-engineered and it fixed it. And her experiment was like a tiny, tiny sliver of the tip of the iceberg of what living things are actually capable of doing. And nobody is talking about this in the public. Now, any competent biologist knows about transposition and knows who Barbara McClintock is. Like, especially if they have a degree, okay? But there's this whole random mutation, natural selection, survival of the fittest story that is told to people. And even in biology, they don't start unlearning that story until they're probably a sophomore or a junior. And actually, that story is already baked in, and it colors everything they think they know their whole entire profession. Like I said before, as a communication engineer, I know for an absolute fact that random copying errors are not what is going on here. It is deliberate engineering by the cell that obeys specific patterns. In fact, in my book, Evolution 2.0, I describe it as a Swiss Army knife, and it has 5 blades. Like, there are 5 major categories of genetic changes that cells do to themselves, and transposition is one of the 5. And this is so sophisticated and so amazing. I really think it is the biggest untold story in science.
Is this, or I guess you can relate and contrast this with, is this intelligent design behind this, or is this, how is this different from that view, or is it?
So intelligent design means a lot of things to a lot of people. So to some people, intelligent design means sophisticated creationism. Okay? And to some people, intelligent design means evolution is not true. If you're reading the New York Times, intelligent design almost always is presented as meaning anti-evolution.
Yeah.
Okay? And there's this organization called the Discovery Institute, and they are the advocates of intelligent design, capital I, capital D, and they are perceived as being against evolution for the most part. I don't subscribe to intelligent, like that political version of intelligent design. I would go with lowercase I, lowercase d in the general, in the largest sense, but evolution as an engineered process. Either the first cell was designed with the capacity to adapt and adapt and adapt and adapt, or the universe is so fine-tuned, has such properties that is able to produce a first cell that has these kind of capabilities. Either way you want to go with it, and I'm not too particular, which path you want to go down, but either way, living things are so much more fantastic and amazing than the Darwinian classical story leads you to believe. It's just astonishing. Think of it like this. Did you ever use DOS, like on a computer?
Yep.
Back in the day, right? And it's black and you have the command line prompts. Okay. I want you to seriously, use your imagination for a second. I want you to imagine that Bill Gates and his friends at Microsoft came out with DOS in 1981. And I want you to imagine that no human hands touched DOS ever since. That there was no programmers in Redmond, Washington. There was no project managers. There was no software programmers. There was no software engineers. There was no testing, all this other stuff they do. I want you to imagine that DOS developed a Windows desktop because one was needed. And it developed Excel spreadsheets, and it developed internet connections, and it developed a web browser, and it did all this in real time in response to all of the stuff that was changing around it and all of the threats. It developed antivirus software. It started passing the antivirus updates back and forth between all the computers. I want you to imagine that Bill Gates got that DOS written in 81 and then all by itself, because of its intrinsic capabilities, evolved into Windows 10 that we have now. Now, if Bill Gates did that, would you be impressed?
Yeah, that's crazy. Just have something like that develop to what it is today.
Yes, that's crazy. It's crazy amazing. Well, that's how people of faith should view evolution. It's not evolution versus God. That's completely backwards. Okay?
Oh, I was going to say, in this model, so do you get evolution from species to species still within this, what you're seeing?
Yes, you do. And here's how. So this gets you to two other blades of the Swiss Army knife. So let me kind of go through these. So one of the blades of the evolutionary Swiss Army knife is genome duplication through hybrids. So let me explain what I mean by that. I think everybody knows donkey plus horse equals mule. A horse has 63 chromosomes, a donkey has 63 chromosomes, and a mule has 126. So normally when, if a donkey mates with a donkey, you get another donkey that also has 63 chromosomes. Well, a mule has the chromosomes of both parents. And I think you would agree that a mule is a different species than a donkey, right? It's it's a different animal. Well, mules are sterile, and mules are almost always male, but it's possible to get a female mule on rare occasion. It's possible to get a sterile male mule, and it is possible, not probable, but sometimes you can get a fertile female mule. Well, if you got both and you bred them together, there's a chance you could get reproducing mules and a new species. In animals, you almost always have the sterility problem, and it's rare, but not unheard of. In plants, it's extremely common. The way that we have modern wheat is there's another kind of grass that's like wheat. It's like wheat, and then this other thing, it's like a weed called goat grass, and those two mated and gave us modern wheat. It's a new species. And remember I was telling you about transposition, that Barbara McClintock figured out these things start rearranging. Anytime there's a hybridization event, the next generations of new species, there will be a whole bunch of genetic activity, and they're throwing away stuff they don't need. They're rearranging stuff. There's all this stuff that will then start happening. Okay. And so you can get a new species by crossing two existing species together, and sometimes it will work. And so it is believed that, and this is based on studying the genetics and looking at all the different tree of life and all the different animals, it looks very much like invertebrates turned into vertebrates when two invertebrate from different species mated together. So it's like you get double the chromosomes, double the hard drive space, double the genetic material, and then you have this ability to start rearranging stuff. And so this is how you got from animals with no backbone to animals with a backbone. Then there was another hybridization event that happened later that got you from vertebrate fish to vertebrates with jaws. When jaws appear, they accompany a doubling of the genetic material through a hybridization event. Okay? So you have this tree of life where there's these major branches that happen with hybridization event. Okay? And so this is the number one way that you get new species. Okay? So that's another blade of the Swiss Army knife. Here's another one. A different blade of Swiss Army knife is called symbiogenesis. And here's an example of that. Everybody knows in high school biology, you learn that a chloroplast is the thing that makes plants green. It makes grass green, right? And it's the engine that turns sunlight and carbon dioxide into energy. Well, you know what a chloroplast actually is?
No.
Algae. It is an algae cell.
I didn't realize that.
That is what it is. And what happened was a large complex cell that they call a eukaryote ingested algae, and instead of eating it, the algae started reproducing inside, and they developed a symbiotic relationship where I'll give you a safe home and you convert sunlight into energy, and we got a great partnership. It's like a Starbucks and a Marriott.
Yeah.
Okay? Mitochondria are the things in your cells that convert oxygen into energy. It's the exact same thing. A mitochondria is a bacteria that lives symbiotically in the cells of your body. And mitochondria and chloroplasts are both, the theory says that this is what happened based on piecing the puzzle pieces together. But there are actual experiments where they've gotten this to work. There's a guy named Quan Zhang. He put amoebas and these bacteria together, and for 18 months they fought like cats and dogs, and it killed most of them. But 18 months into his experiment, he actually got them to go into a symbiotic merger where now the bacteria are living inside the amoeba. Both of them cut, spliced, rearranged, changed their DNA, changed their body chemistry, changed their relationship to each other. And when he separated the two, both of them died.
So I guess one of my questions on this is, this sounds fairly convincing. Why is it not more known out there, more promoted out there?
Well, not only is it convincing, it's been in the literature for anywhere from 50 to 100 years. I kid you not. In fact, if you don't know anything about this, you wouldn't even know where to look. You wouldn't know what to look for. I was just banging away, and eventually a friend sent me something, said, hey, I think you'll think this is interesting. And then all of a sudden, I'm on the trail. A guy figured out the first symbiogenesis epiphany was in 1867. The Russians had it pretty much all figured out by 1930. Barbara McClintock figured out transposition in the 40s and 50s and got a Nobel Prize in 1983. This has been around a long time, and competent biologists all know about it. So here's what's going on. I mean, I'm going to cut to the chase. Here's what you got. Remember I said there's the loud guys on the left and the loud guys on the right, and I quickly figured out, don't listen to them, right? It was my engineering instincts that said, don't listen to them. Okay? It's like, dude, I know science really well. Are you going to tell me engineering is not science? I don't think you can say that, right? So the creationists, especially the really super conservative ones, they're like, evolution is bad. It's hoax. It doesn't fit the Bible. We can talk about the Bible later if you want. I'm still a Christian, okay? This is not going to make you not a Christian. They think evolution's a hoax. They cannot see the evidence.
Yeah, I can see that.
Okay? They're like, bad, get away, no. Yeah, we believe in microevolution. We don't believe in macroevolution. You can't get a new species, blah, blah, blah. Okay? They're against it, right? And they spent a lot of money and they got a lot of media and, you got Ken Ham debating Bill Nye, right? Mm-hmm. And I'm not sure which one of them is worse. Okay? They're both bad. But let's go over to the atheist side. Well, this whole random mutation, natural selection story is really, really convenient for the atheists because it sounds like it just explains everything. But then it's, well, why didn't they teach me that in engineering school? And why isn't there a single software engineering company in the world that uses random mutation and natural selection to write software? Like, why don't they just build 10 million servers and just
let them go?
Let them go. Right?
Yeah.
How come that doesn't work? Because neo-Darwinism doesn't work. That's why. And so it's been dominated by these two sides. Not only that is the money. The version of Darwinism that you hear from Richard Dawkins really started in the 40s. It didn't start with Darwin. Darwin's version of evolution was actually more accurate than the one you read in textbooks. Origin of Species is a better evolution book than a Richard Dawkins book is now. And I'll give you an example. This is another blade of the Swiss Army knife, is inherited traits. So there's a woman I met 2 months ago in London. She's a biologist. She did this experiment where she had these plants and she took identical clone seeds, and these one grew in bright sunlight and these one grew in a dim room. The bright sunlight ones, they grew narrow, thick leaves. The dim room, they grew wide, broad, thin leaves that catch a lot more sunlight. Now that makes sense.
Yeah.
Okay. Well, here's what she did. She took the seeds from those plants and then she planted them, and the ones from highlight plants grew up with thin leaves, and the ones from low light plants grew up with thick leaves, even though they're in the same light. In other words, the learning of how big to make the leaves was transferred to the very next generation in real time.
Yeah, it's a lot faster than...
Yeah, it's like next generation adapted. Darwin believed that was possible. He had no idea how. There was a guy named Lamarck that came up with that idea 200 years ago. The idea that you could inherit something that fast was completely rejected in the 1940s, and it was wrong. This is actually called epigenetics, and it's a huge growing field of study. We don't even know to the extent how much, just going through your life, how much of what goes on gets passed on to your kids. Don't even know. But what I can tell you is every single generation of everything on Earth has been shaped by generation to generation inherited epigenetic adjustments all through Earth's history. So living things are incredibly adaptive. Richard Dawkins does not want you to know this. Because this just wipes out his whole Darwin got rid of God 150 years ago story, which not even Darwin would agree with. And so evolution has been completely bastardized by the atheists. It's been ignored by the creationists, and it is literally, I absolutely think this is the biggest untold story in the history of science. I had to write this book. Like, nobody's writing this book. And again, if you go get a PhD in biology, you'll know all this stuff, but the average person never hears any of this, right? You're a smart guy. You got a podcast. You talk to all kinds of people, and you've never heard this stuff, right?
No.
And it's not because you're hiding in a cave somewhere. Like, nobody's telling you. The schools aren't teaching it. The universities aren't teaching it. And neo-Darwinism has to go. Neo-Darwinism being the 1940s version of evolution that most people hears, it's 2/3 wrong. It's got to go.
So I guess I've kind of put myself in a place of, someone just going along with their life here and not really, I don't know if evolution and faith may be a strong part of their life, but maybe it's an aspect of their life. I mean, what's the impact on someone like that from your position?
Well, I've had a bunch of people write Amazon reviews or write to me or whatever, and they're like, Perry, I read your book and I suddenly saw Evolution 2.0. I suddenly saw the world in this completely different way than I ever did before. Like, my goodness, the world is astonishingly engineered. But you have to accept that evolution is also a very chaotic process. Like, survival of the fittest is true.
Mm-hmm.
But it's not anywhere close to the whole story. It's a little fraction of the story. Because, like, that whole symbiogenesis thing of symbiotic mergers, nature is an incredibly cooperative. Nature is incredibly adaptive. And so, if you could summarize my book in 2 sentences, it's this. Darwinists underestimate nature. Creationists underestimate God. So it's like, okay, if Bill Gates can make DOS evolve into Windows all by itself in 35 years, he's a demigod.
Yeah.
And so how much more respect does this give you for how much more amazing the world is than anybody ever actually told you?
Yeah, definitely. That's got me here thinking. That's some stuff to think about for sure.
And I want people to think. I'm not going to tell you what to think. I'm not going to tell you what conclusion to come to. But what I am committed to doing, there's a lot of Christians that are listening, and you're going, okay, so how does that work? And Genesis and everything. There's an appendix in my book. It's called Genesis 2.0, and it says, let's read this just a little bit differently than you were taught to read it, and let's see if this can fit. And so that's where I go. And I think people will appreciate that chapter. What I've really tried to do with my website and my platform and the book and everything is create an environment. I call it a demilitarized zone. Between North and South Korea, there's this mile or two strip of land where nobody gets to shoot at each other. Nobody gets to kill somebody, right?
Yeah.
And Evolution 2.0 is a demilitarized zone where people can discuss the science.
Yeah.
And you know what? You can come with any view that you come from. You can be an atheist. You can be a young earth creationist. You could be a Bible scholar. You could be a Buddhist. You could be a Muslim. You could be whatever. We are going to vigorously discuss the scientific facts, and we discuss and we debate. But nobody gets to be rude to each other. Nobody gets to be mean to each other. Nobody gets to call each other names. And you can't be anonymous. You have to use your real name, and you lay your cards on the table. And we discuss. And this does not exist out there. It is so polarized. I mean, talking about evolution, you might as well be talking about abortion, gun control, gay rights, immigration. I mean, yeah. It's as polarizing. It makes people as angry as anything. And mostly the two sides just talk to each other. Hey, wait a minute. Hey, what about Barbara McClintock's thing? And what about the fact that this happens all the time, every single day? What about inherited, learned characteristics that get passed to offspring? Like, how deep does that rabbit hole go? Like, is that why, like, dad was an alcoholic, grandpa was an alcoholic, great grandpa was an alcoholic? There is so much for us to figure out here.
I love it. I love the thought-provoking nature of this. I think it really fits into a lot of this podcast is basically for us to expand our thoughts and to think about things we haven't thought about before. And I think this is a beautiful illustration of that. One of my questions here is, I guess, what advice would you have for someone who may be coming upon this the first time, maybe has struggled in some of these areas of evolution or creation or their faith? Would you have any advice for them?
Yeah. Number one, be curious. I mean, really curious. Like, how does that work? How does that work? And you got to understand, you never get to the bottom of that rabbit hole. There's always more. There's always more. You know, one of the things that just breaks my heart about Darwinism, like the way most people are taught, is it just kills their curiosity. Like, oh, okay, so all you need is just billiard balls banging around in the universe and natural selection, and you get us. Oh. And all the stuff that you can learn just gets swept under the rug. It literally dumbs people down. There's a woman named Mae-Wan Ho. She died last year, brilliant evolutionary biologist. She said, neo-Darwinism dulls the mind. You should be curious. You should be going, well, how does that work? Well, how does that work? How does that work? You can spend your whole life and you can be happily chasing down these mysteries. Another one is never fear or ignore any verifiable facts. Another piece of advice is, what is the agenda of the person who is talking to me right now?
Yeah.
And look, everybody's got one. Sometimes it's getting their research grant. Sometimes it's turning you into an atheist. Sometimes it's turning into a young earth creationist. You know, it's like, but what is their agenda?
Well, let me turn that on you then. What is your agenda, Perry?
I have two ambitions in my life. One is to start a second renaissance, and the other one is to heal the rift between science and religion. I don't think there's any conflict between science and faith at all. In fact, science requires faith in a whole bunch of things you can't prove just to even practice it.
Yeah.
And anybody who has studied the philosophy of science knows this. You can't prove the sun's going to come up tomorrow. You can't prove that the law of gravity isn't going to go haywire 12 minutes from now. All you can do is rely on the so far reliable properties of the universe. And how did they get discovered in the first place? They got discovered because mostly very religious people said, I think God made an orderly universe that's discoverable and understandable, and I'm going to find out what the rules are. That's why we have science. It's no coincidence that most of the early breakthrough scientists like Copernicus and Newton and Boyle and Maxwell and all these titans of early science, almost all of them were deeply religious people. Why? Because science was an act of worship. Like good. I am peering into the mind of God when I study the folding of this protein. And that doesn't mean I think God said poof and the protein appeared. God created a process, and I'm studying the process. I'm studying the rules. What are the rules of the game? I don't think we've even begun to scratch the surface. Nobody in the world can tell you what consciousness is and how it works.
Yeah.
Nobody. Like, so let's just start there, right? So, I mean, this amazing mystery that we have in the world. You know, viva figuring it out.
Yeah, that's cool. I like that. Keep discovering, keep finding, keep being curious.
I would challenge anybody to, you know, read my book, Evolution 2.0. Read 100 pages. For that matter, read like 5 chapters and see if it doesn't really provoke your curiosity and literally have you looking out the window and going, wow, you know, I've looked at that tree for 17 years. I never realized that every single green, you know, cell in that tree is green because there's an algae living inside of it.
Yeah.
Right.
That's cool.
And that is the world's first successful merger acquisition. You know, and so you can use biology as a springboard for your thinking about whatever else you do in your life. I certainly have used it, and we don't have time to go into it, but I've certainly used it in my career. So,
All right. Well, in closing up here, I'd like to hear, as you look towards the future, what's exciting to you? What do you see coming up?
Well, I think so. I was at a conference less than 2 months ago. It was in London. It was at the Royal Society, oldest scientific organization in the world. And it was about new paradigms in evolution. And it was all the stuff that we're talking about. And it was the first major conference where this new stuff was the center stage main topic. Okay.
Wow.
So in other words, the scientific establishment has been very slow embracing this. Also, what we're going to see in the next 20 years is a radical change in the direction of basic science and especially evolutionary science. I can guarantee you in 20 years, neo-Darwinism will be ancient history. It will. It is not surviving the onslaught. I was at this conference and watching the old school guys backpedal was frankly pretty amusing. Because there is no counter argument. There is no counter argument to Evolution 2.0. Okay? Read the 1-star Amazon reviews. Most of them don't have any substance whatsoever.
Yeah, I think I looked at some of those, yeah.
All right. There is no counter argument to this new way of looking at evolution. It's only a bunch of questions about, so what's really going on here? And so I am very excited about where science is going. I think it's really going to start to be liberated, and I just hope people will, put on their thinking caps and really ask the questions.
Beautiful. Well, Perry, I really appreciate you coming on StoryHinge and sharing that message with us, and I look forward to expanding my mind and looking more into this as well. So thank you.
Well, Jason, I appreciate being on. By the way, the book's on Audible and Kindle, so all the different versions. I appreciate you being on, taking a little bit of a risk. The person that helps me get these appointments, I mean, a lot of times these hosts don't have any idea what they're in for, and so thanks for taking a chance. I really appreciate it.
Hope you enjoyed that one with Perry Marshall. To find his book, you can go to Amazon.com and look under Evolution 2.0. Also, please subscribe to the podcast. We'll continue to bring you more interesting topics and ideas. And visit the website for feedback, for ratings and reviews. And have a great week.